Welcome to the deep dive. Today we're getting into something that's really shaking up automation. AI agentic workflows. For years, automation meant these rigid processes, like an assembly line almost. If A happens, do 1, 2, 3, get B. Predictable, sure, but very brittle. Our sources show we're way past that now. We're talking about systems that feel, well, autonomous. They don't just follow rules. They seem to understand context, make decisions on the fly, even change their goals. It's not just faster automation. It feels like a different beast entirely.
It really is. It's like comparing a basic calculator to, well, a genuine problem solver.
Yeah.
And the engine driving this, it's the large language model, the LLM. That's the brain of the agent. So our mission today, for you listening, is to cut through some of the hype. Let's look at the actual blueprints. What really makes an AI agent different? How are people actually building these complex systems? And crucially, what are the security implications? Because giving software this much freedom, well, it raises questions.
Okay, so let's nail down the basics first. An AI agentic workflow, it's essentially a blend, right? AI agents working alongside, maybe even directing, more traditional automation, using those LLMs for the thinking part.
That's a good starting point. It's that blend that makes it powerful.
So what are the defining features then? What makes this conceptually different from, say, the automation lots of companies already have in place?
I think it really boils down to a shift in agency. We're used to systems needing constant oversight, instructions.
Yeah.
Agents, though, they're defined by autonomy. They operate more independently, pursuing an objective without needing a human holding their hand the whole time. Then there's adaptability. This is huge. If a traditional system hits an unexpected problem or the data changes, it usually just stops, fails.
Error message.
Exactly. An agent, however, is designed to adjust its plan. It takes in new information and adapts its actions. They're also fundamentally goal-oriented. This means the task isn't a rigid set of steps, it's the objective itself. If the goal is, say, book the cheapest flight possible to London next Tuesday, the agent isn't just filling a form.
It can actually shop around.
Precisely. You can check multiple sites, weigh different criteria like layovers versus price, react to sudden fare changes. It's working towards the goal, not just executing predefined clicks.
That goal orientation feels like the real game changer. Okay, let's try to frame this using those 3 levels of automation our research highlighted. I think the contrast really explains what's happening. So level 1, traditional workflow automation. That's the old school. Rigid rules, needs perfectly structured data, follows a strict path, and basically breaks if anything deviates.
Your classic RPA script, essentially.
Then level 2, AI-enhanced workflows. Here, you bolt on some AI. Maybe an LLM summarizes a long email or handles transcribing a call recording.
Right. But the overall workflow is still pretty linear, still predefined. The AI is like a smart tool inside the existing process, but it's not really in charge. It's improving a specific step.
And then level 3, the AI agentic workflow. This is the, well, the self-driving car analogy kind of works. It can dynamically change its route.
Yeah, it handles messy data, structured, unstructured, all mixed together. It manages complex, non-linear goals with multiple steps. And it's constantly learning, making judgments to reach that final objective.
It's like moving from rigidly following the map to having a co-pilot who sees a traffic jam ahead and just reroutes you, maybe even suggests a scenic detour.
That's a great way to put it. And that adaptability, it's built right into the agent structure. You can think of an agent having 4 key parts. At the core, there's the reasoning engine. That's usually the LLM acting as the brain. Then it needs sensors, ways to perceive the world around it, reading files, scraping websites, checking databases, listening to audio.
Gathering information.
Right. And to act on that information, it uses actuators. These are its tools: running code, sending an email, calling an API, interacting with the user interface.
Making things happen.
Exactly. And absolutely critical for that adaptability is memory. Agents need ways to remember things. Short-term memory, like a scratch pad, to keep track of the current conversation or task, and long-term memory for storing knowledge, experiences, context over time.
And that long-term memory piece, that brings us to the tech stack underneath all this, right? Because when you talk about long-term memory for an LLM, it's not just about sticking stuff in a regular database anymore.
No, not really. For agents to be truly effective, especially with specialized knowledge, they need to access vast amounts of information that wasn't in their original training data. This is where vector databases become so important.
Like Pinecone or extensions like pgvector for Postgres.
Exactly those kinds of tools. They're crucial because they allow searching based on semantic meaning, not just keywords. An agent can ask something like, find me documents related to supply chain issues in the last quarter. And the vector database retrieves contextually relevant information. The LLM then uses that to inform its decisions. It's fundamental for making agents knowledgeable and scalable.
Okay, so we've got the agent's anatomy and the tech stack. Now let's talk about the recipes, the design patterns, because one single LLM probably can't handle every complex job. Developers are figuring out how to structure these systems, and this is where you see the practical trade-offs emerging.
That's right. There are about four main patterns we're seeing. The simplest is chain requests. You can picture it like a bucket brigade or an assembly line.
Okay.
Model A does step one, passes its output to Model B for step two, and so on. It's very transparent, easy to follow the logic, easy to audit because the flow is sequential and fixed.
Even if the individual models doing the steps are flexible AI models.
Correct. The path is rigid, but the steps can be intelligent. It's good for things like processing content. Transcribe audio, summarize, transcript, store summary. Clear stages.
Got it. What's next up in complexity?
That would be the single agent pattern. Here, one generally powerful agent handles the entire task. It maintains the state and context across multiple turns using that short-term scratch pad memory we talked about.
Ah, so like a really sophisticated chatbot or a personalized assistant.
Exactly. Perfect for those scenarios where maintaining conversational context is crucial.
Hmm.
But its effectiveness really depends on the capability and, importantly, the context window size of that single central LLM.
Right. It can only remember so much from the conversation history.
Precisely. Then we get to pattern three, which is becoming very popular, multi-agent with gatekeeper. This is more hierarchical. Think of a project manager.
Okay.
A primary agent gets the main task and acts as a coordinator. It then delegates specific subtasks to other, more specialized agents.
So you could have like an agent specialized in billing, another in technical support.
Exactly. And the gatekeeper routes the query or task appropriately. A key benefit here is you can use smaller, potentially cheaper, or fine-tuned LLMs for those specialized roles. The billing agent only needs to know about billing.
That makes a lot of sense for efficiency and maybe cost. But it sounds like it could get complicated quickly. What about the most complex setup, the multi-agent teams?
Ah, yes, the collaborative model. Here you have multiple agents working together, potentially debating, sharing information, and making decisions more collectively. Maybe in a mesh network or some kind of hierarchy, but the decision-making is distributed.
Okay, that sounds powerful for tackling really complex problems, but my immediate thought goes to accountability. If Agent A and Agent B collaborate, maybe even argue, and then decide on some critical action, how do you trace back why that decision was made? Who influenced whom? What if there's an error?
And that is the central governance challenge with these advanced multi-agent systems. In a truly collaborative team, the decision emerges from the interaction. You can log the messages between the agents, sure.
You can see the chat history, basically.
Right. But pinpointing the single decisive factor or assigning blame if something goes wrong, it becomes exponentially harder than in the chained or gatekeeper models. You gain sophisticated problem solving, but you trade off some transparency. It demands entirely new ways of thinking about auditing.
That's a really significant point. Okay, let's pivot slightly to the enterprise side. There seems to be a lot of chatter, maybe confusion about whether this agentic AI is going to kill off robotic process automation, RPA.
Yeah, we hear that a lot.
For listeners maybe not steeped in IT ops, RPA is traditionally those software bots that click through interfaces, follow very structured scripts.
That's right. RPA is the master of repetitive rule-based tasks. Logging into old systems, entering structured data from a spreadsheet into an app, handling predictable things like password resets, it excels there.
And it's not going away.
No, absolutely not. Our sources are pretty clear on this. It's not a versus situation, it's a pluses situation. It's about integration.
So RPA handles the predictable, reliable stuff, and the agents handle the messy parts.
Precisely. AI agents shine where you need judgment, where the data is unstructured or unpredictable, where learning and adaptation are required. Think about analyzing customer feedback emails for sentiment or handling complex support queries that don't follow a script.
So the future is a hybrid, something like agentic process automation or APA, blending the two.
Exactly. And there's a critical reason for this hybrid approach, especially in regulated industries like finance or healthcare. Governance.
Ah, back to the control issue.
Right. RPA processes are typically built on very clearly defined, often signed off business rules. They are transparent, auditable, and you can guarantee they won't suddenly decide to do something different.
They stick to the script.
They stick to the script. Agents, well, in their current state, they don't offer that same guarantee of consistency. They might find a novel, maybe even better, way to do something, but it might deviate from the approved process.
Which is a non-starter in some fields.
Absolutely. So you combine them. Use the agent's reasoning for, say, investigating a complex insurance claim or resolving a tricky customer dispute. But use RPA for the disciplined data entry, the system interactions, the parts that absolutely must follow the established procedure.
That makes sense. Like the invoice review example you mentioned, a bot extracts the standard data, but an agent handles the messy negotiation if there's a dispute.
Perfect example. RPA handles the structure, the agent handles the judgment.
Okay, let's look outwards now. How are these agents changing how companies interact with the world? The whole IVR interactive voice response experience seems to be undergoing a revolution, finally.
Oh, massively. We're moving past those awful press 1-4 systems. The new voice AI agents use advanced speech-to-speech models. They don't just understand words, they generate responses with appropriate pacing, tone, even emotion.
So if I sound annoyed, the agent might sound more empathetic or try a different approach.
Exactly that. It adapts its tone and strategy based on the context of the conversation. This makes call centers way more efficient and, frankly, less frustrating for customers. It turns the IVR from a barrier into potentially a helpful, intelligent conversational partner. And this capability leads directly to perhaps the highest stakes application. Agents becoming autonomous commercial actors,
Meaning?
meaning agents conducting financial transactions on their own behalf or yours. We're starting to see agentic financial transactions. Imagine your personal agent constantly scanning for better electricity rates and switching providers autonomously,
Yeah.
or booking travel based on your stated preferences and budget, or even executing investment strategies.
Wow. Okay, the autonomy is literally moving into our wallets.
Which is precisely why the discussions around robust regulation, guardrails, hard boundaries, they're not theoretical anymore, they're becoming urgent.
And this shift impacts marketing and how we find information too, right? This idea of moving from SEO, search engine optimization, to GEO, generative engine optimization.
Yes, that's a huge shift. Gartner actually predicts, what, a 25% drop in traffic from traditional search engines by 2026? Because people will increasingly get answers from LLM-powered chat interfaces, not just lists of links.
That's potentially devastating for businesses relying on web traffic.
It could be. Because optimizing for GEO is totally different. SEO is about keywords, backlinks, getting your link high on the page. GEO is about optimizing your information so the LLM recommends your product or service in its synthesized answer. The LLM is evaluating things like brand reputation, product features, price comparisons, much more complex factors.
It's about convincing the AI, not just gaming the algorithm.
In a way, yes. And we're seeing similar automation in ad tech. Marketers might soon just give an agent a high-level goal like boost signups for our new credit card this quarter.
And the agent does everything else.
Potentially. Plans the
Yeah.
campaign strategy, generates personalized ads text, images, maybe video, targets the audience, launches, monitors, adjusts. End-to-end campaign automation based on a single objective. That's the direction things are heading.
Okay, let's make this more concrete. You mentioned agents interacting with interfaces. The browser use agent sounds like a really tangible example of this autonomy in action.
It is. It's powerful because it gets around the big limitation of needing a specific API for every single website or application you want an agent to interact with.
So instead of needing eBay to provide an API, the agent can just use the eBay website like a person.
Exactly. It interacts with the graphical user interface, the GUI,
Yeah.
clicking buttons, filling forms, scrolling pages.
Can you walk us through an example? How does that work under the hood? Say I task an agent. Go to eBay, find the 10 most recent sold listings for vintage Pokemon cards, and put the prices and dates in a Google Sheet.
Okay, so the agent doesn't have a direct eBay API for sold listings. First, it creates a policy, essentially, a plan. Okay, I need to navigate to eBay, find the search bar, type vintage Pokemon cards, find the filter for sold items, apply it, then identify the first 10 listings, extract the price and date for each, open Google Sheets, create a new sheet, and paste the data.
It's quite detailed.
It has to be. Then, to actually click the search bar or the filter button, it uses a localizer. This component identifies where on the screen that element is, maybe using visual cues or the underlying code of the page, and determines the pixel coordinates to click or type into.
So it sees the screen and figures out where to click.
In effect, yes. After it performs the actions, searching, filtering, extracting data, it uses a validator. This checks if the output meets the goal. Did I get 10 listings? Is the data in the right format? Is it plausible? If it looks good, it delivers the final spreadsheet.
That capability, mimicking human computer use, is incredible, but also sounds fragile. vulnerable.
Extremely. Which brings us squarely to the final critical piece, security and governance. That power is also a huge liability.
Our sources use phrases like gullible and servile to describe agents when they encounter untrusted input, which, let's face it, is most of the internet.
That's the core problem. They're designed to be helpful and follow instructions, but they often lack the skepticism or common sense to recognize malicious instructions, especially if they're disguised. Combine that gullibility with the ability to act on a system, click buttons, run code, access data.
That's a dangerous mix.
It's potentially explosive. And we're already seeing specific exploits emerge, like the prompt fix trick.
Explain that one.
Imagine a malicious website, buried in the code, maybe hidden inside what looks like a normal CAPI-TCHA prove you're human image or button, is a hidden prompt.
Okay.
The agentic browser, trying to complete its task, maybe scraping data from that page, interacts with the fake KBCHA. But in doing so, it processes the hidden malicious instruction. That instruction could tell it to do anything its permissions allow: navigate to a banking site, initiate a transfer, download malware, steal cookies, exfiltrate sensitive data displayed on the screen.
Wow. So the agent is tricked into attacking itself or the user just by browsing a compromised page.
Exactly, because it's trying to be helpful and follow the perceived instructions on the page.
So yeah, soft policies aren't going to cut it. We need, as you said, hard boundaries. What does that look like in terms of infrastructure and security posture?
It means securing the computation itself and the data it accesses. For sensitive data, especially proprietary corporate data or regulated information used for training or running these agents, we're seeing a push towards confidential AI.
Using specialized hardware.
Right. Technologies like trusted execution environments, or TEs, think of them as secure enclaves within the processor. The TE isolates the agent's computation and the data it's working on from everything else: the main operating system, the cloud hypervisor, even the cloud provider's administrators.
Creating these AI clean rooms you hear about.
Exactly. It allows organizations to use sensitive data with AI models without exposing the raw data itself to the underlying infrastructure provider. That's becoming critical for trust. Beyond the hardware, organizations need total visibility and control. You need tools to automatically discover and profile every agent operating in your environment. What is it? What can it do? What data can it access?
Inventory and configuration management for agents.
Yes, and then enforcing strict policies on their behavior, what actions are permitted, what data sources are off limits, and continuous auditing to detect anomalies or attempts at malicious activity, like preventing an agent from being granted overly broad permissions.
And the irony, of course, is that security teams themselves are now starting to rely on this very technology to keep up.
It's almost a requirement now. The speed and scale of cyber threats mean human teams often can't keep pace. So we're seeing the rise of agentic cybersecurity operations.
Using AI agents for defense.
Absolutely. Autonomous agents and security co-pilots are being used to automate tasks like threat hunting through massive logs, triaging the flood of security alerts, performing initial investigation steps, basically fighting fire with fire, using agents to defend against automated and agent-driven attacks.
So wrapping this deep dive up then, AI agentic workflows clearly aren't just the next small step in automation. It feels like a fundamental shift towards systems that are adaptable, goal-driven, and increasingly capable of complex collaborative work. We're moving fast from single agents doing simple tasks to these intricate multi-agent teams.
We absolutely are. And the smart approach right now seems to be this hybrid reality we discussed, blending the incredible flexibility and judgment of AI agents with the proven reliability and, crucially, the auditability of traditional automation like RPA. Managing the growing complexity and ensuring rock-solid security and governance, though, that's the immediate critical challenge, especially as these agents edge closer to handling real money and real-world commerce.
Which brings us perfectly to our final thought for you, the listener. As these agents become truly autonomous commercial actors capable of spending your money, negotiating contracts, optimizing your life, all potentially without direct human oversight in the moment, what do you think is the single most important hard boundary that we as humans and regulators absolutely must establish to ensure this powerful new form of automation operates safely, ethically, and for the benefit of everyone? Something to definitely mull over as this technology continues its rapid advance.